Okay, welcome to the solution to problem 15 in chapter 12. I'm going to do this the easy way. I think I've already shown this to you in a lecture video. But basically the problem is we're going to roll two dice and then sum them and then calculate the probability of getting a 7. And the book is saying, look, use the VLOOKUP table. Now, I'll show you what it looks like, but I'm not going to use it, right? So the idea here is I'm going to have these 6 outcomes, right? So 1, 2, 3, 4, 5, 6. And then my lower bound on the VLOOKUP, so for the first one, it's going to be a 0, right? And then all you're going to do is add 1 divided by 6. Oops, I screwed, that's this, plus, and then 1 divided by 6, right? That's the increments, right, for a die roll. So I'll just copy that down. This is what your VLOOKUP table should look like if you use the VLOOKUP table, all right? But the reason I'm saying that is I wish this question wouldn't have been, use the VLOOKUP table, because in all honesty, there's a much easier way to do this. And I showed you how to do this in one of those lecture videos, but just do die 1, die 2, and then here's my sum. Use the rand between function. This rand between function is just like the rand function, except it's for a discrete uniform distribution. So the rand function models a continuous uniform distribution between 0 and 1, whereas the rand between is a discrete uniform distribution that allows you to set the lower and upper bounds. So for a die roll, the lower bound, let me get the function first, rand between, there it is. Okay, so obviously for this one, the lower bound is going to be a 1, and then your upper bound is going to be a 6, and there you go. You've simulated rolling a die, right? So this first one I rolled a 4. Now I rolled a 1 and a 4, and then I want to take the sum. There we go. Okay, now I want to simulate this about 1,000 times. So we'll do that real quick. Just hit the page down and hold it for a while. Get into there, that's plenty. All right, paste. Okay, now it says, what is blah, blah, blah. What is your simulation estimate of the probability of rolling a 7? Okay. So here, so I'll type that, rolling a 7. Okay. So essentially this is kind of like the probability of a loss, except now it's the probability of rolling a 7. So the point being is first you want to count how many 7s were simulated. So that's my count if function. Count if, highlight my range, okay, and then my criteria, excuse me, my criteria is 7. I want to count all of the 7s that were in that column. Okay, I've got 186. And then here, the probability of a 7, well, that is going to be the number of 7s we simulated divided by the total number of simulations. So this could be equal to this number divided by, now I want to count how many simulations I ran. So I'll get my count function, count, and count all of these. So I ran 1,213. So the probability of getting a 7, according to my simulations, is right around 17%. And again, I suspect even if you just ran 1,000, the probability of getting a 7 is going to be right around 17% due to the law of large numbers. All right? Well, there you go. There is problem 15 in its entirety.